Welcome to Spaceverse, your portal to cosmic adventures. Scientists have just made a groundbreaking discovery, a massive underground reservoir of liquid water on Mars. And get this, it's so vast that it could cover the entire planet with water to a depth of 1 to 2 kilometers, or about a mile deep. This revelation is huge because it solves a long-standing mystery about Mars. What happened to all its water? Mars wasn't always the dry, dusty place we see today. Billions of years ago, it had a much thicker atmosphere and a warmer climate, which allowed liquid water to flow across its surface. So how do we know this? Well, there are 3 key pieces of evidence that show water once flowed on the red planet. First up, we have a network of valleys and outflow channels. Mars is dotted with features that look a lot like river valleys and deltas here on Earth. These branching valleys suggest that liquid water once flowed across Mars, carving out channels and depositing sediments. The second line of evidence is the presence of hydrated minerals. Scientists have detected minerals that only form in the presence of water, such as clays, sulfates, and certain types of salts, which strongly suggest that water once existed on Mars. These minerals have been identified by orbiters like the Mars Reconnaissance Orbiter and rovers such as Curiosity. Additionally, Martian rovers have uncovered sedimentary rock formations on the planet, similar to those formed by water-related processes on Earth. These layered rocks often display features like cross-bedding, which forms when water flows over a surface, and ripple marks created by moving water. However, between 3 to 4 billion years ago, Mars underwent a series of catastrophic events that drastically changed its history. The downfall began with the collapse of its magnetic field. Unlike Earth, Mars lost its global magnetic field relatively early in its history. This magnetic field, generated by a dynamo effect within the planet's molten core, would have protected the Martian atmosphere from the solar wind, a continuous stream of charged particles emitted by the sun. As Mars's core gradually cooled, the dynamo effect weakened, eventually leading to the loss of its magnetic field. Without its magnetic field, Mars's atmosphere was left exposed to the relentless solar winds. Over time, this bombardment eroded much of the atmosphere, causing the atmospheric pressure to plummet. As the air thinned, it became increasingly impossible for liquid water to remain on the surface. Water that once flowed freely began to evaporate and escape into space. The thinning atmosphere also led to a diminished greenhouse effect, causing temperatures to drop sharply. Mars gradually transformed from a warm, wet environment into the cold, dry world we see today. As the planet cooled, any remaining liquid water froze, forming surface ice or permafrost hidden below the surface. But a puzzle remained. Even after considering the water lost to space, there should still be a substantial amount left on Mars. The ice caps at the poles didn't account for all the missing water. This raised an intriguing question. Where is the rest of Mars' water hiding? And if it still exists, could it potentially support life as we understand it? The breakthrough came with NASA's InSight lander, a mission designed to explore Mars' internal structure. Unlike earlier missions that focused on the surface, InSight was tasked with probing deeper into the planet's interior. Its mission was to study Mars' seismic activity, measure heat flow, and analyze its internal composition by looking beneath the crust. During its 4-year mission, InSight detected over 1,300 Marsquakes. These quakes were caused by meteor impacts and volcanic activity, sending seismic waves through the planet's interior. These waves provided geophysicists with the opportunity to explore Mars' inner structure. Hidden within the seismic data was an unexpected discovery: a substantial underground reservoir of liquid water. This finding was made using a technique similar to those used on Earth to study its internal structure. By analyzing how seismic waves move through different materials, seismologists can deduce the properties of those materials. To pinpoint the location of this hidden water on Mars, scientists employed a rock physics model similar to those used on Earth to map underground aquifers and oil fields. The model suggested that the seismic data could be best explained by the presence of a layer of fractured igneous rock deep beneath Mars' surface, with its cracks filled with liquid water. Igneous rocks form when molten rock, either magma below the surface or lava above it, cools and solidifies. This process can occur in various geological settings, such as beneath volcanoes or as lava flows after eruptions. As igneous rocks cool, they often develop fractures and cracks, which can create pathways for water to flow through and be stored in the spaces between the cracks. Over time, weathering can further expand these cracks, allowing more water to seep in. While igneous rocks are not typically known for being highly porous or water retentive, under certain conditions, they can indeed hold significant amounts of water. While the discovery of this underground water reservoir on Mars is a significant breakthrough in understanding the planet's water cycle, the fact that it's located at depths between 11.5 and 20 kilometers or 7 to 13 miles presents a major challenge. These depths are far beyond the reach of current technology, and even on Earth, drilling to such depths would be an extraordinary feat. This makes accessing this water practically impossible for future astronauts or with the tools we currently possess. The presence of liquid water on Mars doesn't necessarily imply that life exists there, but it does open up fascinating possibilities. The conditions within this deep underground reservoir might resemble environments on Earth where microbial life thrives, such as in deep mines or on the ocean floor. Researchers suggest that if Mars harbors habitable conditions, they are most likely to be found deep beneath its surface. This discovery underscores the importance of understanding Mars's water cycle, not only to trace the planet's climate history, but also to assess its potential to support life. If life ever existed on Mars, or if it still does, it could be hidden within these deep underground waters, awaiting discovery. With the revelation of a vast water reservoir, it's tempting to envision Mars as a potential future home for humanity. However, landing humans on Mars remains a distant goal, with several formidable challenges in the way. One of the most significant obstacles is the sheer distance between Earth and Mars. On average, Mars is about 225 million kilometers, or 140 million miles from Earth. A round-trip mission to Mars would take approximately 18 to 30 months, factoring in travel time to Mars, a stay on the planet, and the return journey to Earth. Such a mission would require astronauts to carry sufficient supplies to last the entire duration. Moreover, the vast distance also means that communication delays would make immediate help from Earth impossible, posing a serious risk if any emergencies arise during the mission. The second major challenge is radiation exposure. Space is filled with dangerous cosmic rays and solar particles that can pose significant health risks to astronauts. While Earth's magnetic field provides us with protection from much of this radiation, Mars lacks a similar shield. As a result, astronauts traveling to Mars and spending time on its surface would be exposed to levels of radiation that could increase their risk of cancer and other serious health issues. The third challenge is the harsh Martian environment. Mars has an extreme climate, with surface temperatures that can plummet to negative 125 degrees Celsius at night and only rise to about 20 degrees Celsius during the day in the summer. Additionally, Mars is known for its frequent and sometimes planet-wide dust storms that can last for weeks or even months. These storms could disrupt solar power generation and damage critical equipment. Ensuring the safety and functionality of both astronauts and their gear in such a harsh environment is a significant hurdle. The fourth challenge involves life support systems. Sustaining human life on Mars will require reliable systems to provide essential resources like air, water, and food. Unlike Earth, Mars has a very thin atmosphere composed mostly of carbon dioxide, with very little oxygen and almost no accessible water. This means astronauts will need advanced life support systems to generate oxygen, recycle water, and either produce or bring along enough food for the mission. These systems must be exceptionally reliable, as any failure in Mars' unforgiving environment could be catastrophic. Finally, there's the challenge of maintaining physical and mental health. Prolonged exposure to microgravity during the journey to Mars can lead to muscle atrophy, loss of bone density, and a range of other physical health issues. Upon arrival, Mars' lower gravity, only about 38% of Earth's, could also have unknown effects on the human body. On top of these physical challenges, the psychological toll of such a mission is a major concern. The crew will face isolation, confinement, and the psychological strain of being millions of miles from Earth, which could lead to stress, anxiety, and depression. Ensuring the astronauts remain both physically and mentally healthy throughout the mission is a complex challenge that will require careful planning, continuous support, and innovative solutions. The discovery of this massive water reservoir on Mars has added an exciting new layer to our understanding of the planet's history and its potential for future exploration. While tapping into this resource might be a goal far off in the future, it certainly fuels the imagination about what could be possible as we continue to explore and learn more about Mars. On a related note, China recently returned with a sample of lunar soil from the far side of the moon. Their successful series of missions suggests they might be on track to become the first nation to establish a permanent base on the moon. If you missed this episode, make sure to catch up on this fascinating update. And that's it. Thanks for joining us on this journey through the latest discoveries on Mars and beyond. If you're as fascinated as we are about the mysteries of the universe, from hidden water reservoirs on the red planet to the race for lunar exploration, make sure to hit that subscribe button and stay tuned for more. Here at Spaceverse, we're always exploring the cosmos, uncovering the secrets of our solar system and beyond. Until next time, keep looking up and imagining the possibilities.